Hi, this is John Linneball from John Linneball Tutoring, and we're going to cover Chapter 6H of Barron's SAT Premium Study Guide. That's the 30th edition. If you have the 29th or 28th edition, it doesn't really make much of a difference. It doesn't make that much of a difference even if you have an older edition than that, but I wouldn't suggest using anything older than the 28th edition, which I believe is just called Barron's New SAT. So this is John Linneball Tutoring. I'm at 1859 Powell Street, number 109, San Francisco, California, 94133, and that's 415-986-7355, john at johnlinneball.com, johnlinneballtutoring.com. Without further ado, let's get started. Problem 1, page 544. In the afternoon, Judy read 100 pages at the rate of 60 pages per hour. In the evening, when she was tired, she read another 100 pages at the rate of 40 pages per hour. In pages per hour, what was her average rate of reading for the day? So we know the afternoon rate would have been 100 pages divided by 60 pages in 1 hour. So we can see pages cancels out, so we get 100 over 60. So it's 100 hours over 60, which is 5/3 of an hour or 5/3 hours. I don't care whether you can say it's 5/3 hour or 5/3 hours. Evening rate, 100 pages over 40 pages per hour. Same deal. Pages, those cancel out. So we have 100 over 40. That's 140 hours, which 100 over 40 hours, which is 5/2 of an hour. So we have to find the average rate by finding the total pages, which is easy. We know it's 200 pages. It's just the afternoon and the evening, and then dividing by the total time. The total time is 5/3 hours and 5/2 hours, which is 10 over 6 plus 15 over 6, because the common denominator is 3 times 2, which is 6. So we have to multiply this 5 by 2, so you get 10/6. And this 5, since you're multiplying the 2 by 3, you have to multiply this 5 by 3. Plus 15 over 6, which is 25 over 6. That becomes 200 pages over 25 divided by 6 hours. So then we end up with 200 pages over 25, which is 8, times 6, which is divided by hour. So we end up with 8 times 6 pages per hour, which is 48 pages per hour. That's answer B, not C, which is 50. 50 is what you'd get if you had just averaged the reading rates, which is tempting, but sometimes doing things the longer way is the only way to get it done right. Or as people say, sometimes the short way is the long way. Problem 2, page 544. What is the largest of 5 consecutive even integers if the sum of the first 4 is A? So the easiest way to do this is just plug in simple even numbers, then find the answer choice that gives you the right answer. You may have to try different numbers if you end up with more than one answer that works with your first set of numbers, but hopefully you'll understand which formula is right before it comes to that, because you'll see how the problems work. If it doesn't, fine, pick different numbers, and I guarantee you only one answer will work with your new set of numbers, especially since you've already limited it to 2 answer choices. So let's try 2, 4, 6, 8, and 10. Thus, A is equal to the sum of the first 4, which is 2 plus 4 plus 6 plus 8. You can do this little neat trick. 2 plus 8 is 10, 4 plus 6 is 10, 10 plus 10 is 20. So 2 plus 4 plus 6 plus 8 is 20. Problem 2, page 544, continued. So again, what is the largest of 5 consecutive even integers if the sum of the first 4 is A? So we're going to take 2, 4, 6, 8, and 10. Again, A is equal to 20. So the answer choices are A plus 10 over 5, A plus 10 over 4, A plus 20 over 5, and A plus 20 over 4. So choice A gives us 20 plus 10 over 5. That's 30 over 5, which is 6. Nope, doesn't work. Okay, 30 over 4... is, 20 plus 30 plus 10 is 30 over 4, that's 7.5. Remember, we're looking for 10. So C is 20 plus 20 over 5, that's 8. Close but no cigar. And then we have 20 plus 20 over 4. Hey, that's 40 over 4, that's 10. So the answer is D. Now, again, if you want to do this problem algebraically, you can. It's easier just to substitute in easy numbers and do it that way, but if you are not convinced that you can do it, or you can be confident unless you do it algebraically, let's do it this way. You want to solve for x plus 8, that's the biggest even number, in terms of A, where x is an even number, and x plus 2 plus x plus 4 plus x plus 6, the first 4 even numbers, equals A. So by combining like terms, we get 4x plus 12 equals A. So we need to get x plus 8 from 4x plus 12. So we divide by 4 to get x plus 3, and then we have to add 5 to get x plus 8. So now we go backwards to put this in terms of A. Our first clue is that we had to divide by 4, so now we have to multiply by 4. So the answer has to be, 4x plus 12 plus 5 times 4 over 4, because we need to get this 5 in terms of everything else over 4. So It's going to be A plus 20, because, this is A, and, so A plus 20, because 4x plus 12 is A over 4. This is much harder for most people, including me, so I suggest you'd use the first method on the SAT rather than this one, even though the second method would show that you actually understand it. Problem 3, page 544. A jar contains only red, white, and blue marbles. Yeah, sorry, couldn't find a drawing online that had just red, white, and blue, so this will have to do. And the number of red marbles is 4/5 the number of white ones, and the number of white ones is 3/4 the number of blue ones. If there are 470 marbles in all, how many of them are blue? Well, let's have B equal the number of blue marbles, R equals the number of red marbles, and W equals the number of white marbles. Easy enough, right? So B plus R plus W equals 470. We know that W is equal to 3/4 B, so we can just substitute in 3/4 B for W. And R is equal to 4/5 W, so R has to be 4/5 times 3/4 B. Remember, that's W, so it's equal to 3/5 B. So we just substitute in. So now R is 3/4 B, and then, R is 3/5 B, so this one's R. W is 3/4 B, and then of course B is just B. So the common denominator is going to be 5 times 4, so it's 20. So, okay, this one you have to multiply by 5, so this 3/4 becomes 15/20. And 3 times 4 over 5 times 4 becomes 12 over 20. So these add up to 27 over 20. B is, of course, 20 over 20, so you end up with 47 over 20B is equal to 470. So B is equal to 470 times 20 over 47. So then, okay, we know that 10 times 47 is 470. There's a 47 on the top. This is 47 times 10. You can see those cancel out. So you just end up with 10 times 20, which is equal to 200, which is choice C. Problem 4, page 544. As a fundraiser, the Key Club was selling 2 types of candy, lollipops at 40 cents each and chocolate bars at 75 cents each. On Monday, the members sold 150 candies and received $74. How many lollipops did they sell? Well, okay, let's let L equal the number of lollipops, C equal the number of chocolate bars. So we know that C plus L is 150 because the total is 150 candies. And so C is obviously 150 minus L. So let's do this in terms of cents and lollipops, because we want to solve for lollipops. They ask how many lollipops did they sell, and since it's 40 cents and 75 cents, we can just convert the $74 to 7,400 cents. So we know that 40L plus 75 times 150 minus L equals 7,400. So we go 40L minus 75L plus 75 times 150 is 7,400. So we get negative 35L plus 11,250 equals 7,400. And then just doing the math on that, you end up with 3850 is equal to 35L. So L is equal to 110, choice D. Hopefully this will be on the calculator section, but it's just going to be a little annoying if you actually have to do the math. Most likely this will be on the calculator section, though. Problem 5. This is a coaxial cable, in case you're wondering what this picture is. Star Cable Company charged $75 to install a cable line in the customer's home and a fee of F per month for the customer to access the cable service. Of course, I think most people just get their cable TV through the internet and high-speed connections, but hey, some of you have cable modems, some of you still have cable TV. But I digress. Anyway, so fee of F per month to access the cable service. At the end of 2 years, the customer paid the cable company a total of $2,043. What is the value of F? So, since the installation charge is a one-time fee, we can subtract $75 from $2,043 to get $1,968 for 2 years, or 24 months. Since F is a monthly fee, we see that 24F is equal to 1968. So if 1968 over 24, F is equal to 1968 over 24, which is 82, choice B. Problem 6, page 544. Aaron has 3 times as much money as Josh. If Aaron gives Josh $50, Josh will then have 3 times as much money as Aaron. How much money do the two of them have together? I found this one surprisingly tricky, so let's set it up. A is equal to 3J, where A is Aaron's initial money and J is Jason's initial money. So it's how much money they start with. So we know that J plus 50 is equal to 3 times A minus 50, where they say if Aaron gives Josh $50, then Josh has an extra 50. Aaron's now down $50, and Josh now has 3 times as much money as Aaron. So we're going to substitute 3J for A, so then J plus 50 is equal to 3 times 3J minus 50. Now we distribute, so J plus 50 is equal to 3 times 3J, 9J, 3 times negative 50 is negative 150. So combine those like terms to get 8J, because we're just going to subtract J from each side. And then we're going to add 150 each side. 8J is 200. So J is 25. So A equals 3J equals 3 times 25 equals 75. So the total is A plus J is 75 plus 25 equals 100, which is choice B. Problem 7. I'd like you to meet Jason here. This is Jason for our purposes. If half of X years ago Jason was 12 and half X years ago from now he will be 2 years old, how old will he be 3X years from now? Well, alright, let J be Jason's current age. So we know that J minus 1/2 X is 12. And then they're also telling you that he'll be 2X years old in 1/2 X from now. So then we know that 12 plus 1/2 X plus 1/2 X equals 2X, so 12 plus X equals 2X. Okay, you should be able to figure out pretty quickly that X must be equal to 12. So 1/2 X equals 6 and 3X equals 36. So 2X has to be equal to 24 for what it's worth. Okay, so we can see that 12 plus 1/2 X equals 12 plus 6 equals 18, so Jason is 18. And J plus 1/2 X is going to be 18 plus 6 is 24 equals 18 plus 6, so it all checks out. So therefore, Jason's age 3X years from now, remember 3X is 36, is 18 plus 36, which is 54, choice D. I found this to be a very hard question, despite how fast I just went through it right now. So that's why it's important to check to make sure these other values check out so you know you haven't made a mistake. Problem 8, page 545. 2 printing presses working together can complete a job in 2.5 hours. Working alone, press A can do the job in 10 hours. How many hours will it take press B to do the job by itself? Now, this is an extremely common SAT and ACT and GRE and GMAT. Those are 2 graduate tests, 2 tests you'll take to go to graduate school or to business school, etc. problem. And GRE and GMAT math are basically exactly the same as SAT math, at least the general GRE. And the GMAT, I guarantee you, it's just high school math. So one job equals 10 hours times R sub A, where R sub A is the rate at which press A works. One job equals 2.5 hours times RA plus B, where RA plus B is the rate at which presses A and B work together. So we can quickly see that R sub A is just one job over 10 hours, so it can do one job in 10 hours. And R over A plus B is one job in 2.5 hours. So that's going to be one job over 5 halves, which is 2/5 of a job per hour. So the combined rate is the sum of the rates. So A plus B is R sub A plus R sub B. So that's going to be 2/3 of a job per hour equals one job per hour, or sorry, not one job per hour. 2/3 of a job per hour equals 1/10 of a job per hour plus R sub B, which is the rate at which press B would do it alone. So R sub B is going to be 2/5 minus 1/10, which is 4/10 minus 1/10, which is going to be 3/10 of a job per hour. In case you don't know how I did that, 2/5, you multiply both the numerator and the denominator by 2, so you end up with 4/10, so you have a common denominator. 4 minus 1 is 3, so you end up with 3/10 of a job per hour for press B. Since work equals rate times time, just like distance equals rate times time, time is going to be work over rate. One job over 3/10 of a job per hour equals 10/3 of an hour, or 3 1/3 hours, which is choice A. Problem 9, page 545. Henry drove 100 miles to visit a friend. If he had driven 8 miles per hour faster than he did, he would have arrived in 5/6 of the time he actually took. How many minutes did the trip take? Notice that the time is to be expressed in minutes and that it's underlined. It's so you can't argue that you were tricked, even though it's as close to a trick question as the SAT can make without causing a huge uproar. So let t equal the time in hours. We need to find 60t, which is the time in minutes. So first of all, let's just solve for t. So let r equal the rate at which Henry drove in miles per hour. Then r miles per hour equals times t hours equals 100 equals r plus 8 miles per hour. You can just multiply r plus 8 times miles per hour times 5/6 times t hours, because the rate, the time would have been 5/6 whatever t is. The 100 just drops out. We can just set these equal to each other, and we can also drop the units here. You can leave them in to check to make sure you did the math right, which is what I normally recommend, but I'm confident enough here to take them out. So we get RT equals 5/6t times r plus 8. Let's divide by t on both sides, so the t drops out. So then we just end up with r is equal to 5/6r plus 46. So 1/6r, we just subtract 5/6r, is equal to 40 over 6. You should easily see that r must be equal to 40, since you just can multiply by 6 on both sides. So we know Henry drove 100 miles at 40 miles per hour, so that's 100 over 40 miles per hour, which is 2.5 hours. But wait, that's not an answer. It's not listed. We had to give the answer in minutes. So 2.5 hours is 150 minutes, or choice D. One problem I do have with Barron's SAT is sometimes they don't have good wrong answers. 2.5 really should have been an answer here, since many people would have chosen that. Seeing that's one of the tricks that they were pointing out here and that we're using here, I'm a little surprised. But anyway, other than that, it's a good problem. Problem 10, page 545. Since 1970, when Martin graduated high school, he has gained 2 pounds every year. In 2000, he was 40% heavier than in 1970. What percent of his 2015 weight was his 2000 weight? We know his weight in 2000, we'll call it W sub 2000, equals 140% of his weight in 1970, which is W sub 1970. So W sub 1970 is 100 over 140, times W2000. We also know that W2000 equals W1970 plus 60, because 2000 minus 1970 is 30, and 30 times 2 is 60. So we know that W1970 is going to be equal to 5/7 W1970 plus 60 equals 5/7 W1970 plus 5/7 is 60. So 2/7 of the weight in 1970 is equal to is equal to 5/7 times 60, and then W1970 is equal to 60 times 5 over 2, which is 300 over 2, which is 150, so W2000 is equal to 2010, because it's 150 plus 60. So the percentage W2000 is of W2015, his weight in 2015, is 210 over 210 plus 15, so it's 15 years, times 2, so it's 210 plus 30, so that's 210 over 240, which is 7/8, which is equal to 0.875, or 87.5%. You can see that answer choice in your book. So let's move on. Problem 11, page 545. What is the greater of two numbers whose product is 900 if the sum of two numbers exceeds their difference by 30? So let's call the numbers A and B, and we'll let A be the larger number. So we know AB, the product is 900, and A plus B is equal to A minus B plus 30. So we can combine like terms. We can add B to each side to get 2B, subtract A from each side to get rid of it. So 2B equals 30 and B equals 15. So then we can find the larger number simply by dividing 900 by 15, which is 60. Problem 12. The number of comic books in Fred's collection is 60% of the number in Phil's collection. If Phil has 60 more comic books than Fred, then how many do they have altogether? Well, F is equal to 60% of P, where F is the number Fred has, P is the number Phil has. F is 60% of F plus 60. So we know that 3/5, because that's 60% of F plus 60, is equal to 3/5 F plus 36. So 2/5 F equals 36, and F is equal to 5/2 times 36, which is 5 times 18, which is 90. So P is equal to 90 plus 60, which is 150. F plus P is equal to 150 plus 90, which is 240, which is the right answer. Problem 13, page 545. Karen played a game. Maybe she was playing roulette, like in this old-timey picture of Las Vegas. And Karen played a game several times. She received $5 every time she won and had to pay $2 every time she lost. Not very realistic. They would probably also take $5 every time she lost. But anyway, if the ratio to the number of times she won to the number of times she lost was 3 to 2, and she won a total of 66, how many times did she play the game? So let's have the number of times won equal to W, the number of times lost equal to L. So W over L is equal to 3 over 2, and L is equal to 2/3 of W, and 5W minus 2L, because it's $5 per win, and you lose $2 per loss, is equal to $66. Therefore, 5W minus 2 times 2/3 W is going to be 11/3 W, because this would be 15/3 minus 4/3. So 11/3 of W is equal to 66. So the total number of times Karen won was $66 times 3 over 11, which is just going to be 3 times 6, because 6 times 11 is 66, so the 11s cancel out, so 3 times 6 is 18. Since we know she lost 2 times for every 3 times she won, she lost 18 times 2/3 times, which is 12 times. So the total times, sorry, there should be an S there, she played is 18 plus 12 equals 30. Problem 14, page 546. Each of the 10 players on the basketball team shot 100 free throws, and the average number of baskets made was 75. When the highest and lowest scores were eliminated, the average number of baskets for the remaining 8 players was 79. What was the smallest number of baskets anyone on the team could have made? They say in the book anyone could have made. Well, it could have been somebody sitting over here made some. So we just mean the people on the team. Ha ha ha. Anyway, notice that the higher the highest score was, the lowest score could have been. So first we calculate the total baskets made, which is just the average, times the number of players. So it's 75 times 10. So the total points, you can always find the total points of whatever value by multiplying the average times the number of individuals providing those values, or just the number of individual values. So in this case, you multiply baskets made by basketball players, you get 750 total baskets made by all the players. So, we know that the total number of baskets made by all the players was 750. We are told the average, once the highest and lowest scorers were eliminated, was 79 for the remaining 8 players. So we can quickly find the total for the remaining 8 players is 8 times 79, which we can write as 8 times 80 minus 1, which is 640, because 8 times 8 is 64, add a 0 on the end, minus 8 equals 632. That's kind of a neat use of the distributive property that will help you if this is on the non-calculator section, or if you just don't want to stop to use your calculator, or your calculator breaks or runs out of power. Pro tip, get a solar powered / dual powered calculator, or bring additional batteries, or hey, you could even bring an extra calculator, not an extra category or whatever I was about to say. Anyway, any of those things will help you out, so you won't have to not use your calculator, but this is kind of cool because it means you don't have to take the time to use your calculator. So 750 minus 632 is 118, so the combination of the high and low scores is 118. Again, the low score is the lowest when the high is the highest, so let's say the high score was 100, the guy made all the free throws, the highest score possible, then the lowest score is the lowest possible, and that's 118 minus 100, which is 18. Problem 15. In an office, there was a small cash box. One day, Ann took half the money in the box plus $1 more. Then Dan took half the remaining money plus $1 more. Stan then took the remaining $11. How many dollars were originally in the box? There's an easy way to do this. Work backwards. We know that Stan took $11, and we know that it's $1 less than half the money in the box before Dan came and took money. So half of what was there when Dan came is $12, so it would have to be $24 before Dan took any of the money. So that's 24 when Dan took half plus 1, which would be 13. So the 24 is $1 less than half the amount in the box when Ann took the money. So half the original amount is 25, and the original amount in the box is $50. That helps you avoid some really ugly algebra here, so which you can go and look in the book to see how that is. I'm not going to set it up for you right here. This is the SAT way rather than the way that your math teacher would hope you know how to do it, even though doing it the long way will help you when you're doing real math in college and in life. That's not what I'm here for. I'm here to help you maximize your score on the SAT. So, for best results, use the Barron's SAT 30th, 29th, or even the 28th edition. This video, in case you haven't figured it out, covers page 544 to 546 in the 30th edition of Barron's SAT, either the normal Barron's SAT or the premium SAT study guide. And the page numbers are the same in the 29th edition, and they're identical or close enough in the 28th and previous editions. You shouldn't use an edition older than what I believe is the 28th edition, Barron's new SAT from 2016. Okay, it might have been from 2015 because it was published in anticipation. Boy, sometimes my tongue doesn't work right. Of the new SAT, which started in 2016, which is the current SAT format. Not everything in the book is in these questions. Please do read the Barron's SAT book. Watching these videos is better than nothing, but it's not as good as if you actually use the Barron's SAT or some other SAT book. The older editions of this book can be had cheaply, if not for free, from used booksellers, kids who've already taken the test, and public libraries. They do sell old editions, or you can borrow the current edition. If you plan to use a library copy, or you plan to go buy a new edition, I suggest you start early. There's really no worse feeling than needing a library book someone else has checked out, or trying to buy a review book at a store just to find out that it's sold out. Also, look, come on, if you're trying to start 2 days before the test, you'll get some improvement, but you're really not going to optimize your score, how well you can do. Okay, so did you find this video useful? If you did, please like it and subscribe to this channel if you're watching this on my YouTube channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? It's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time. I also don't have anywhere near 1,000 subscribers. Last I checked, at about 747. So, for the same reasons, you're not only welcome, but encouraged to share links to this video, put it in playlists, etc. I'm always happy to read and respond to constructive criticism or suggestions for new videos. I'd appreciate your input. Even if you found a mistake in my video, go ahead, put it in the comments, contact me. I'm happy to admit when I'm wrong. I reserve the right to delete comments from and block those who specialize in destructive criticism, trolls, or things that are off topic, spammers and disturbed people. So you can contact me on my cell phone, which is 415-623-4251. You can text me if you want on the same number. You can email me at john@johnlinneball.com. You can mail me at 1859 Powell Street, number 109, San Francisco, California, 94133. And if you have a copyright issue, you think I've used your intellectual property without permission or not within the fair use provisions of the copyright laws, please contact me. I'm a pretty reasonable person. I'm sure you are too. And in any event, thanks for watching, and there is more contact information to follow if this isn't enough for you. So you can contact me on Facebook, Instagram, email, or phone. The Facebook, it's www.facebook.com, Tutoring. Instagram, www.instagram.com, john.linneball.tutoring. Phone, 415-986-7355. That's my home office. And email, john@johnlinneball.com. Website is johnlinneball.com or johnlinneballtutoring.com. And you can find my new locals.com page at testpreparation.locals.com. And I will have some exclusive content on there soon, as well as everything that you see on this YouTube channel or on my Facebook page, wherever you might be watching this. All right, thanks, and hope you're having a good day.